Hi, this is George from Expit. Today we're going to talk about Expit Registered Mail plugin, which is an Ethereum-based blockchain plugin provided by Expit to demonstrate how we can, with minimal modifications, enhance email security using blockchain. Our agenda for today includes an introduction about the system, how it works theoretically, a demo to see it working practically, and we will conclude with action steps you can take afterwards if you're interested in this idea. So let's start by our introduction. We at Expit Labs developed an Outlook plugin that can demo the added value of using blockchain on top of the existing email system. We managed to apply the idea of the normal registered mail to the email world. We were able to achieve a simple approach to making trusted and trackable email messages a reality. Our solution components are an Outlook plugin and a smart contract published on Ropsten Tetnet on the Ethereum blockchain. Now, let's look how our solution works theoretically. The sender will encrypt the email using a shared key. The email ID of that encrypted email will be uploaded to our smart contract along with the recipient's Ethereum public address. The sender will then send the newly created encrypted email. Once the email is received, the recipient will hash that email and upload the result to the blockchain for confirmation. The sender will then validate the hash value provided. Once confirmed, the sender will then send to the recipient the key required to decrypt the email. After receiving the key, the recipient will use that key to decrypt the original email and reveal its contents. Now let's move to our demo. Moving to Outlook, as you can see, this is a typical new email form with all of its normal content, the from, the to, the subject, and then we have an attachment which we are sending hello to our support team, and this is the email body as well. In this upper section is the Outlook plugin we have created. We created it in steps this way for the demo purpose to show each step as detailed theoretically in the presentation earlier. The first step is to encrypt the email. Once we click, we will be prompted to enter the shared key that will be used for email encryption. For the demo purpose, we are going to write it demo. We click OK, and then we can see the result. The email is encrypted and ready to be sent, which is a message to the sender. This is the original email with its attachment as well. It's encrypted with the shared key that we entered previously, which is demo. The encrypted email hash is this one. Now, we are showing it here for the demo purpose for comparison once you receive the email, but in real-life scenario, the email hash will be generated by the sender to keep for email verification later on. This is the email ID which will be uploaded to the blockchain. Once the first step is done, we upload the email ID to our smart contract. As mentioned earlier, we are going to upload it along with the recipient's Ethereum public address. This is the recipient's Ethereum public address, which should be known by the sender beforehand. We click Upload, and then we get a confirmation that the email ID was added successfully. Now, if we go to our Ethereum contract page on Etherscan website, we'll see that there is a new transaction that has been posted, and here we go. Our transaction is now published. Since everything is ready now, we're going to send the email to that email address. We click Send, and then we wait for the email to be received. Here you go. The email was received. As you can see, this is the plugin part of the recipient side, and it's also constructed in steps for the demo purposes as well. Now we're going to click Reply in order to see the rest of the steps and complete the flow between the sender and the recipient. However, in the live scenario, all the steps that have an asterisk, like step number 4 and step number 6 and 7, will be performed in the background with no intervention from either the sender or the recipient. We now have completed steps 1 and 2, which are encrypting the email and uploading the email ID. Step 3 is confirming the receival and uploading the email hash. Now, since we've received the email now, we need to confirm that the recipient received the correct and untampered email. So once we click Step 3, we will see this form. The first field is the recipient's Ethereum public address and its private key, because this will be a published transaction and there will be gas consumption. The email hash, as I told you before, we didn't delete this one for the comparison purpose, and we can see that this one is matching that one. This is the email ID that was generated by the sender. And this is the public encryption key of a public-private encryption key pair created by the recipient that is going to be used by the sender to encrypt the shared key that was used earlier in encrypting the original email, and this one is uploaded by the recipient. Now once I click Confirm, we go to our Etherscan contract page, and as you can see, we have a new posted transaction. Giving it some time, now the transaction is published. Now we have completed now Step 1, 2, and 3. Now going back to the sender to complete Step 4. Since the email hash was uploaded to the blockchain by the recipient already confirming the email receival, the sender is ready to reveal the shared key after confirming the email hash and verifying that the valid email arrived. So once we click here, we get an email hash and public key. This is the email ID that needed to be checked. We click Check. And this is the info the sender got from our smart contract, including the email hash. We are comparing now, and both hashes are the same. Both sides have verified that the email was received without any alteration. The second thing is the public encryption key provided earlier by the recipient in order to encrypt the shared key used previously. We click OK. Now we're going to confirm the email hash after verifying it as well as the shared key used earlier in encrypting the original email. Now, since we have now the public encryption key, we're going to use it in encrypting the shared key. And this is the encryption result, and the shared key is encrypted. We click Confirm, and email hash was confirmed successfully. We go back to our Etherscan page, and we can see now a new transaction that has been posted. Giving it some time, the transaction is published successfully. Back to the recipient to complete the process. Now, since the shared key was encrypted and uploaded already to the blockchain, The recipient will click Get Encryption Key in order to retrieve it, and as you can see, it was collected successfully. We will click OK. Now we're going to complete the final step, which is decrypting the email. This is the encrypted share key. We click Decrypt, and as you can see, it's decrypted correctly. We click OK, and now we're being asked to save the decrypted email. We click Save, and email was decrypted successfully. We open it, and here you go. This is the email that was sent originally. Back to our presentation and moving to our conclusion. We've just introduced registered mail to the email world. This simple solution provides email with powerful security and tracking features that solves many challenges only partially solvable today via expensive investigations and audits. We can use the blockchain to enhance email security without interfering with the way email works today. If the same idea is applied to other systems, it will result in quick improvements to many existing platforms without the daunting effort required to build new platforms from scratch. For further information, please check the links below in the video description for a downloadable version of the solution. It's code on GitHub and our social media accounts. Also, you can contact us via email at info@expit.com. Thank you for watching our video, and we hope you liked our solution. Bye!